Not a very standard astronomer. Somewhat strange astronomer.
In fact, Philip James Peebles is a theoretical cosmologist. And this is his universe, his Princeton University office, where he makes painstaking calculations to explain the birth and evolution of the universe.
When I got into this subject, I was quite uneasy about it because it seemed so speculative.
Back in 1964, Peebles and his teacher, Robert Dicke, showed that a universe which began with a Big Bang should be filled with heat radiation, which would be detectable at microwave frequencies.
This is an invention by my teacher, Bob Dicke. The device that was used to discover this thermal radiation from the early universe.
1 year later, Dicke and Peebles found what they sought, but they were 1 month behind two physicists from the Bell Laboratories, for which they were awarded the Nobel Prize.
I think the feeling that the Princeton group was not the first to discover it was one of slight disappointment, but I think much more strong was the feeling there is actually something there to measure. And of course, if you can measure, you can learn and discover about the nature of our universe, a wonderful new window. It was the excitement more than anything.
Peebles likens the microwave background radiation left by the Big Bang to ripples in a pond.
If we had had a larger container, the wavelength would be different. So by studying the nature of these ripples in the water, one may deduce the presence of this boundary even if I couldn't see it.
Likewise, studying the background radiation has led to estimates of the age, composition, and geometry of the universe, even to figure out the first moment of the creation of the universe. Today, we know that about 13.7 billion years ago, the universe evolved from a hot, dense plasma to the highly structured cosmos we see today. But new discoveries have sparked new queries. Cosmologists probing the total content of the universe know that the visible stuff, such as galaxies, actually take up about 5%. Another quarter is cold, dark matter. The remaining 70% is something which acts to push the universe apart. It's known as dark energy, which Peebles is still studying.
The dark energy, it is purely hypothetical, invented, not by magic, I would say, but by imagination, to fit the observations.
Back on Earth, Peebles enjoys strolling around the Princeton campus.
So I get inspiration from nature, but more directly, it's relaxation, it's fascination, it's another aspect of the physical world.
Another relaxing pastime is light carpentry. Scientific research is unlike crafting a chair, where the actual result is quickly seen. Peebles' theories are still hotly debated in the world of cosmology.
I will make proposals that turn out to be quite wrong. So I have a wonderful record of failures. Failures in the sense that a better way was found.
Recent observations have reaped new discoveries. It was previously thought that after the Big Bang, the expansion of the universe would decelerate, but it's now found that the expansion is accelerating. This proves that another form of energy prevails, and as Peebles proposed, one that can be a repulsive force.
That's right, he doesn't talk.
But while Peebles ponders the profound, to his wife, he's just an ordinary guy.
He likes to do what he calls watching the big game on television, which means he sits down in front of the television, turns on the football game, the basketball game, or the hockey game and goes to sleep. But if I switch the channel, he wakes up. Wait, I'm watching the big game.
I'm not the Lord of the universe, nor are any scientists. We are toiling humbly, I hope, to try to understand a bit of the reality that's around us, but in very thin slices. We are so proud that we do know things, some things. We should be proud, but we should not forget that we have many discoveries still to be made.